The overall goal of this patterning procedure is to selectively deposit organic electroactive materials on textiles, which enables the fabrication of wearable organic electronic devices directly on clothing.
This method can help to answer key questions in the field of wearable electronics, especially how to seamlessly integrate electronics with clothing to interact efficiently with the human body. The main advantage of this technique stems from elastic capability of textiles, which allows to warm these textiles comfortably in the close contact with the skin.
First, an idea of this method when we look for a non-traditional way of combining organic electronics with a textile platform in a cost-efficient and industrially scalable manner. This technique was inspired by old Japanese kimono dyeing technique, which we adapted for today's micro-fabrication tools and environment.
To begin the procedure, use a laser cutter to cut a pre-designed electrode pattern into a 125 micrometer thick polyamide sheet to form a mask. Then take a 300 micrometer thick sheet of 100% interlock knit polyester fabric with a knit direction stretch capability of up to 50%. Secure this to a flat, portable surface. In a fume hood, use an automatic tape casting tool to coat the polyamide mask with a polydimethylsiloxane formulation at 6 meters per minute to a wet film thickness of 200 micrometers. Gently place the fabric on the PDMS coated mask and allow the PDMS to be absorbed into the textile structure for 10 minutes.